Hello and welcome to tonight's talk on the evolution of Hitachi trains. I'd like to begin by thanking you all for joining us tonight and hope that you take away some new insights and fresh ideas. Tonight you will hear how Hitachi Trains has evolved the design of their trains to meet the aspirations of their customers in a challenging market. By way of introductions, I will start with myself. My name is Toby Johnson. I'm a Senior Vehicle Engineer at Transport for London, and I'm the chair of the South Eastern Centre of the IMechE Railway Division. I will be chairing tonight's meeting, and I'm joined on the panel by our speaker, Barrie Cottam, and committee member, Chen Ying, who will be giving tonight's vote of thanks. As always, questions can be asked throughout the presentation using the Ask a Question functions on your screens. Barrie will be answering questions at the end of his talk, so please submit your questions throughout the presentation as you think of them. Tonight we have a speaker who is highly qualified to give tonight's talk. I'm sure he will talk candidly about his experiences and provide you with an insight into the world of the rolling stock supplier. It is my pleasure to introduce you to Barrie Cottam. Barrie has over 30 years of strategic, engineering, commercial and operational experience in the rail industry. Barrie has worked at Hitachi Rail Europe for over 5 years and has been Head of Business Development since 2018. In his role, he is responsible for leading the business development team to research, scope and bid new business opportunities for rolling stock and systems within the UK and associated markets. His achievements include being the Hitachi Bid Director for a joint £2.5 billion bid for High-Speed 2 rolling stock with Bombardier, and Hitachi Sales Lead for a joint £3 billion bid for new trains for London Underground, also with Bombardier. He is a chartered engineer and is previous chair of the South Eastern Centre of the Railway Division. Please give Barrie your full attention and I hope that you enjoy tonight's talk. Barrie, I would now like to invite you to give your talk. Thank you.
Okay, well, thank you very much for that introduction, Toby. Good evening, everyone. For those of you who do know me, it's a pleasure to be here, and it's good to get back in touch with the centre where I spent many years as chairman. For those of you who don't know me, I'm pleased to meet your acquaintance, and this without being able to see you, it's difficult to see who's there and who isn't. But I think the more that we do these Zoom type events, the more used and practiced we get to it. But I do have to say it's no substitute for that face-to-face contact and that networking that you do get at the corporate event or at the IMechE events such as tonight. So if I can just kind of give you a quick overview of what I'd like to do. I'd kind of like to give you a quick potted history of how Hitachi Trains has evolved in the UK from its first orders to where it is today, and hopefully where we'll be in the future. And in doing that, I'll stop off at a number of kind of train platforms and a number of landmark events, and then at the end try and draw it all together and invite questions. So I think I will obviously try and be as open and as candid as I can, but fair to say nothing in here is breaching any commercial confidentialities. So please feel free to ask me about it. So if I do hopefully then move on to the first slide. So Hitachi Rail, part of Hitachi, in terms of a very, very brief history of Hitachi, was founded in 1910 by a Japanese engineer, name of Nemi Odera, and the original Hitachi product was an electric motor to be used in agriculture, and then from then Hitachi has kind of spawned and spun and become the big conglomerates that it is now. The first steam locomotive was built by Hitachi in 1920, and the first electric locomotive for Japan in 1924. And then if I skip forward 40 years to the original Shinkansen, the Series 0, of which the picture is on the right-hand side at the top, and they were designed, built, and put into service at the time of the Tokyo Olympics in 1964. The original Shinkansen route, and Shinkansen simply means fast railway, was opened from Tokyo to Osaka in 1964, and from then on it has spawned not only extensions across Japan, across the length and breadth of Japan, but has also spawned copycats throughout Europe and the rest of the world, and that is now the very thriving and successful, very high speed type train service that we have across the world now. Fast forward another 40 years, and 2005 was Hitachi Rail's first order in the UK. This is for the Class 395s for Southeastern. That's the bottom picture on the right hand side, of which much more later. But it was then another 10 years until Hitachi Rail opened the Newton Aycliffe factory in County Durham, and also acquired Ansaldo Breda. Again, landmark in that over doubled the size of Hitachi Rail as an organisation, and introduced a lot more skills and capability and capacity at the same time. So here we are in 2020, and in the UK, Hitachi's got 276 trains already in service, with more to come. There are 6 major maintenance depots, or train maintenance centres as we call them, and we have over 2,000 employees, and they are split between the factory, the maintenance depots, and the corporate engineering and procurement type activities. And the Hitachi Rail has got 13,000 employees worldwide, and it is a global company, as I'll come on to explain. To put that in kind of context within Hitachi as a whole, in 2019, Hitachi Corporate had 803 legal entities or companies that were part of Hitachi, and worldwide there were 295,941 employees. So as you can see, Hitachi Rail is a fairly small cog in what is a very large Hitachi machine, but it's one that it is kind of, say, we've grown the footprint in the UK a lot over the last sort of 15 years, and obviously now a key player in the UK market. If I then move on to Hitachi Rail as a whole, although we'll talk tonight about rolling stock, it's very much more than just a rolling stock supplier. It does traffic management, signalling, digital systems, operations, services and maintenance. And these are all kind of part of the Hitachi portfolio, even if we're not directly selling them in the UK at the moment. What maybe kind of, if you want, gives us something to set us apart from other people. We promise engineering excellence across our full product range, and you know, that's the development of quality engineered and quality manufactured products is part of the company's kind of makeup. And last year, 18 billion journeys were completed using Hitachi technology, and that's in 38 countries worldwide. So say on the global scale, a big supplier, and in the UK, say growing, and we hope to be, say, part of that key systems suppliers. One of the things I think that, in my experience, sets Hitachi apart from the other is there is a consistency of message. There is a tradition, and the Hitachi Mission was originally spawned by the company's founder, and this is about contributing to society through the development of superior original technology and products, and that has been the company's abiding mission for many years. It's what we teach to our new recruits, and that is, say, the Hitachi Mission. There are 3 company values. I mean, there's WA, which is harmony, Makoto, sincerity, and forgive me if I get this wrong, but this is Kaitakusha Saishin, which is pioneering spirit. And again, those 3 values are applied to all Hitachi companies, all industry sectors, and that's what everybody that works for Hitachi tries to, if you want, to bring to whatever problem that they are trying to solve. And let's say those company values, although it's very Japanese, it does apply to the worldwide company. So Hitachi Rail in the UK, Class 395 is what we're originally known for. But if I do go back to how it all started, and this is verification train 1 or V1, and some, although this is before my time at Hitachi, there are people who are around when this was put into service, and I'm sure there are people in the audience who remember it, which was a modified British Rail Class 312. And the purpose of this train was to test and prove the Hitachi traction converters, traction motors, traction equipment in the UK. It was a rolling test bed. It was tested on 25 kV and 750 volt DC supplies, used for the safety case and the type approval and the product approval in the UK, gave a head start into the Hitachi traction equipment coming into the UK on subsequent orders. But the train itself, because it was a rolling program, it moved from test site to test site, and it did retain the original traction for transfer from test sites. So it was a bi-mode even back then. Operated from 2002 to 2005, and then by 2005 this was when we then had the first order for real order in the UK, which was for the Class 395, also known as the Javelin. This was and still is the UK's first and only high-speed train, and by high speed we mean 140 miles an hour. There are other trains that have been designed to achieve that, but they don't operate at that speed in service. The fleet's 29 6-car EMUs, and it was ordered by the DfT for the integrated Kent franchise, which was a kind of a precursor to the current Southeastern franchise, and the trains were ordered by the DfT and by HSBC Rail. Govia won the contract to operate the Southeast or the integrated Kent franchise after these trains had been ordered. What sets them apart for very high-speed trains is they are a 20-metre car length, such that they have a go-anywhere facility within the conventional routes in in Kent, but they are quite high-powered. So in the 6-car, you've got 4 motor cars and 2 trailers, and that is really all about getting the performance on high speed 1. They're a dual voltage train, so 25 kV overhead on high speed 1 and 750 volts DC third rail in the rest of Kent, they have the capability of 140 mile an hour on high speed 1, and they do that sort of day in, day out, and up to 100 mile an hour on network rail, although I'm pretty sure that there is nowhere within Kent where they can or do get up to those speeds, but they're certainly capable of it on third rail. The trains have 3 signalling systems. There's the British Rail AWS TPWS, there's then the TVM and the KVB signalling systems that are used on high speed 1. Integration of those signalling systems into what is a high-powered compact train did set itself its own challenges, but the preview service was introduced in 2009, 6 months earlier than planned, and that was about 4 years after the trains were ordered. And the full service was always intended for the 2012 Olympics, but was put into service sort of earlier than that, and they've run day in, day out now for the best part of 12 years. My significant growth in passenger numbers, very consistently high satisfaction ratings, a success in many ways. My maintenance colleagues are preparing now to do the 12-year overhaul, which is kind of a fairly substantial piece of work. Train reliability is for such a complex piece of kit, and bi-mode is good. And the other thing that in terms of operational experiences, there were some ride problems, particularly on the 140-mile-an-hour sections and also going into the tunnels on High Speed 1, that have required some quite fine wheel, rail, suspension tweaks to kind of minimize the ride problems, and also to enable the trains to comfortably operate on the twisty curves that they find in Kent. Quite a specialist fleet, very much based on Shinkansen technology, fully designed and manufactured in Japan, but now something that there's a lot of people in the UK at the Ashford depot who are fully familiar with the trains now, and so we obviously look forward to taking them on for their second life after the overhaul. Following Class 395, there was then another verification train, or V2, or the Hayabusa. I include this for completeness. This was done round about the time of the Intercity Express program. There was a need for trains to be electrically powered and also self-powered. It was a demonstration of battery traction using a modified HST power car from the Network Rail Network Measurement Train. It was done as a trial both with Network Rail and brush traction. The traction battery itself is underneath the first coach, and technology at the time was such that batteries were very large, were very heavy, and the best place to put it was in the separate coach. It was on trial in 2007. It ran both on the Great Central Railway off the network and on the network as part of the Network Measurement Train circuits, and it was a success. There was a 20% reduction in overall fuel consumption. The train was able to maintain the timings. The idea of the traction was it could switch between battery and diesel. The battery could be used to boost acceleration. It could be used to absorbing brake power, and it could be used to reduce idling in the station. And although this wasn't taken up with the IEP as ordered, you will see that this is pretty close to what is now envisaged for decarbonising a whole range of trains in the near future. For absolute completeness, I include verification train 3, which was a diesel locomotive used for ETCS trials. This is the European Train Control System trials on the Cambrian in 2011. Not really part of the rolling stock evolution, but I've included it for completeness. So moving on, 2012 was what is still the big one for Hitachi. This was the national breakthrough project. This was the DfT's Intercity Express program primarily to replace the diesel HSTs, which had been in service for 30 years. The train is capable of 140 mile an hour, although it doesn't run at that on Network Rail at the moment because of line speed and signalling restrictions, and it comes in both bi-mode diesel, electric and electric multiple unit variants. The initial order was placed by the DfT in 2012 for 21 9-car and 36 5-car bi-modes. These went into service at 2017, and the picture at the top is one of the kind of the launch arrivals at London Paddington. The East Coast HST replacements were ordered at the same time. This is 10 by 5-car and 13 by 9-car bi-modes, and then 12 by 5-car EMUs, and these were put into service from 2018. The EMUs on East Coast also include a single diesel engine, which can be used for auxiliary purposes and also for moving the train in those situations where the electric wires are either disabled or not available. But it is only a kind of a limited movement facility. It hasn't got the same bi-mode capability as the bi-modes which have more engines. There was then an additional order in 2013 by the DfT to replace the Intercity 225s on East Coast. This was 30 by 9 car EMUs, and the last of those trains was delivered a couple of months ago in August, and so all of that order of IEP trains, Intercity Express trains, are now in service. And the total is 122 trains, of which 110 were manufactured in the UK. So more about Newton Aycliffe later, but you can see a significant proportion of those trains were manufactured in the UK. Characteristic of the train is it's a 26 metre car length. Now the 26 metre car is longer than was traditionally the case on the UK. It's designed to be slightly narrower than the conventional 23 metre coaches, and therefore have pretty much the same route availability and gauge clearance as a high-speed train that it replaced with the 23 metre Mark III coach. Because the 26 metre coach has got more saloon space, you can get more what we'd call payload capacity, and that's either seats or catering facilities or toilets or luggage space. You can get more in a car than you would in the 23 metre car length, and therefore you're reducing the amount of running gear to give you a higher capacity. The bi-modes have all got diesel generator units from MTU. It's a V12 engine, sits under the floor on many of the intermediate vehicles, and because it is a V12 and it's quite a big engine, that means that the floor height of the intermediate vehicles is slightly higher than that of the trailer vehicles. The driving vehicles. And if you've ever travelled on one of these trains, you may have wondered why there is a slope down to the vestibule in the leading car, and that's because the intermediate floor heights are higher to fit the engine in. The engines, as originally delivered, stage 3B compliant, which was the latest emissions compliance at the time, and they were delivered at 750 horsepower in the original specification, but subsequently uprated to 940 horsepower on the Great Western units. That is achieved by changing the engine management software. Those of you who are involved in diesel engine maintenance will know that what that also does is push the fuel consumption up, push your engine maintenance requirements up, and therefore does increase your costs. And as a result of being uprated to 940 horsepower, the Great Western trains have also been fitted with a larger fuel tank because of the increased fuel consumption. Now that was necessary because of the delays to the Great Western electrification. It was never planned to introduce 125 mile an hour services with these trains because it was expected that the electrification from London to Bristol and Cardiff would be complete. But when that wasn't the case, one of the functions of the flexibility of this train was that was able to be done. They still run at 940 horsepower to this day, and on those occasions where the wires are not available, you can still get a decent speed out of the trains on diesel. Obviously not as good as they are on straight electric, but an acceptable compromise, we think. Now, as a function of the 26 metre coach, a 9 car has 20% more seats than the Intercity 225 it replaces, and the energy consumption is 18% less than the Intercity 225. So you can see there that there are both capacity and energy benefits involved in going to what is a new design of train rather than the sort of 30-40-year-old trains they replaced. And also note there that the acceleration at 0.7 meters per second is twice that of the Intercity 225 diesels. Because the installed power is not the same as a HS2, if you had a race, eventually a HST would catch up with the bi-mode IEP, but you would be many miles down the route before it caught up. And in the nature of the train service that we run, you'd be getting ready for your next station stop. So in terms of journey times, even on the diesel, you know, the journey times were not much different to the Intercity 225 diesels. Of course, on electric, the journey times are much speeded up. So that was the big one, the breakthrough program. Also in 2015, Hitachi opened the Newton Aycliffe rail vehicle facility. Newton Aycliffe is built on an existing industrial estate, but relatively speaking, it's a greenfield site in near Newton Aycliffe in County Durham. The top picture there shows a plan view, including the main assembly hall, and then to the right, the test hall and the dispatch sidings. But it's a 31-acre site. The main building itself's got 44,000 square meter footprint. It's a big place. The middle picture is inside the main assembly hall. It's designed to be simply an empty hall, and there are rails in there, but not much else. And so you can fit in there your assembly stages as you want, and you can split the factory into a number of manufacturing cells, or indeed you can move in either warehousing, or as we've done at the bottom there, you can move in car body welding facilities. And so the space is quite flexible. It's £82 million was the inward investment in the factory. It was round about 3 years from when building was started in 2014 to the first deliveries out the factory in 2017. And you know, even then, it takes a couple years to get into your stride. There are 700 full-time jobs there, and what we do notice is that most of those are not only new to the railway industry, but most of those are new to manufacturing as well. And there's been some quite intensive training and skilling and retraining of people, you know, to get to the stage now where it is a fully fledged train manufacturing facility. Now, the first trains that were assembled there were pretty much assembled with parts imported from Japan, but we do have a localization program, and over time the supply chain is shifting to what is a more European and UK based supply chain. There are some graphics that show how that's progressing, but pretty much most of the equipment that is not Hitachi generic equipment, like the traction converters and the bogies, you know, most of that equipment is now competitively sourced, and the UK supply chain is getting a bigger role in that. This year we made a further £9 million investment in Newton Aycliffe in car body welding and car body painting, which is to be operational next year in 2021. The cars, I mean, can be 20, 24, 26 meters long. This is, say, it's a substantial welding operation. We do it already at Casado in Japan and Pistoia in Italy, and Newton Aycliffe adds to that capacity, mainly aimed at products that will be manufactured at Newton Aycliffe, but not necessarily the case, depending on what the demand is from the other factories. So then, based on the success of the IEP, the product family of AT300, as we call, we've then had a series of orders placed either with franchise bids or placed with open access operators, with a number of operators and train leasing companies, which are all based on the IEP, but not the same. You know, the the products themselves are both bimodes and EMUs, but the interiors and the customer specification is all absolutely from the operator and from the owner. So again, the interiors will be very different on these, both from the IEP and also from each other. But in 2015, we got the West of England order from Great Western and Eversholt, which was for 5 and 9 car bimodes. Followed pretty quickly in 2016 by 2 orders for Angel and First Group, one for TPE and one for Hull Trains, which were for 5 car bimodes. And then in 2020, the open access operator, First East Coast Open Access, ordered 5 car EMUs from us. Now the difference with those is that EMU doesn't have any diesel engine, and therefore is a pure EMU product. Followed then later in 2020 by the new operator for West Coast Partnership, Avanti West Coast, which is a First Group Trenitalia consortium. Again, took 13 5-car bimodes and 10 7-car EMUs, but from the range. The 7-car EMU has a very similar seating capacity to a 9-car Pendolino. So you know, although it's only a 7-car, there is quite a lot of payload space in it, and for Avanti intend to use those primarily on London to Liverpool services, which will have more stops because it's a new service that they're introducing, and therefore you can use the high rate of acceleration that the train has. Worth noting, it doesn't tilt, so it is not a straight replacement for the Pendolino. These are all 26-metre car length trains. The bimodes are fitted with the 940 horsepower GU, and like as I say, the interiors are all specified by the customer and are very much customised to what they want. So in 2010, the new ScotRail franchise was looking for quite a large fleet of electric multiple units, and Hitachi won that order, which was for 70 trains. The Transport Scotland led the procurement, and the trains are owned by a company called Caledonian Leasing, which is it's SMBC Bank plus some other financiers, and they own the trains and will be leasing them to ScotRail for about 20 years. The EMUs are 3 cars and 4 cars. It's a regional train, 100 mile an hour. The acceleration 0.84 meters a second. It's not quite metro acceleration, but it's certainly faster than an in-city electric. It's a 23-meter car length, 1/3, 2/3 doors, and the interior is pretty much arranged 2x2 seating. Manufactured pretty much in its entirety at Newton Aycliffe. The picture at the top shows the team who were charged with making these trains, and the car body there is how the original ones were imported from Casado in Japan, with the windows already fitted, and the later ones came without that. So it was simply a bare shell that was imported from Japan, and everything else was installed at Newton Aycliffe. It does use IEP technology, and as a result of that, of course, you know, it builds on that service experience. Train went into service in 2018, and this year it was recognised as the most reliable new train in the UK, and also has very high customer satisfaction ratings with ScotRail. Certainly, it's transformed the Glasgow-Edinburgh run, and it's also used on other of the suburban networks in and out of Glasgow and Edinburgh. But very closely identified with ScotRail, and will be in Scotland for many years to come. So another slight digression on the timeline. Also in 2015, it was confirmed that Hitachi had acquired Ansaldo Breda from Finmeccanica. Now, Ansaldo Breda is a company with an even longer history than Hitachi. The original Ansaldo company was 1853 and built many steam and electric units and electric locomotives, primarily for the Italian market, but also increasingly in later years for export. Has design and manufacturing capabilities in Italy, has manufacturing facilities in the USA because of primarily because of the Buy America requirements, and is strong in design and build of metro, regional and high-speed trains. The picture at the bottom, which is the ETR 1000 joint venture with Bombardier, again a very successful, very high-speed train in Europe, based on the Bombardier Zafiro platform, but definitely designed and built for the Italian market. In an 8-car formation, the Italians put in 4 different classes of passenger accommodation, and with all the associated kind of services that go with that. After the initial build, there have been follow-on builds for Trenitalia. The train itself is now used in Italy and France, and will soon be used in Spain as an open access service that's being mainly kind of run by Trenitalia. So quite a big increase in the product range, certainly a big increase in headcount and factory space, but also gave us some different design outlets, which I'll come on to in a minute. At the same time as acquiring all of Ansaldo Breda, Hitachi acquired 40% of Ansaldo STS, primarily the signalling company and the digital products. And in the next 5 years, the remaining stake was acquired, such that by 2019, Ansaldo STS became a fully owned part of Hitachi Rail, and it's now an integrated part of the Hitachi Rail structure. So I said about the design capabilities that we had in Italy and the manufacturing capabilities. The AT300s, the trains that have been supplied to East Midlands trains, are a new design of the AT300 bi-mode. The updates are primarily in the car body, in the way it's assembled, and also the way that the traction configuration works. But it is basically a updated design. 33 5-car bi-modes ordered by Abellio East Midlands and Rock Rail, due in service in 2022. The car length is 24 metres as opposed to the 26 metres of the other AT300s. The 24 metres is primarily driven by the need not to extend the platforms at St Pancras. So a 10 by 4 car train at St Pancras, which is 2 5-car units coupled together, totally fills the available platform space at King's Cross, and therefore that's why it's a 24-metre car body. But of course, that may be something that other customers are also looking for in the future. Unlike the AT300, this is built for 125 mile an hour operation in diesel mode, despite St Pancras Bedford being electrified. The trains probably won't be able to use it in their early years, and so they were specified with 4 diesel engines in a 5-car, which means a redesign of one of the leading cars to take a diesel engine underneath it rather than a transformer. So these trains have 4 diesel engines and 1 transformer, whereas a 5-car bi-mode with the likes of Great Western has 3 diesel engines and 2 transformers. Car bodies will all be welded at Newton Aycliffe, so that's due to start next year, saying the train's in service from 2022. One of the real advantages of this type of bimode design is that as the electrification of the middle and mainline route extends and is upgraded such that it can take East Midlands trains as well as Thameslink trains, is you simply stop using the diesel engines when you don't need to, and eventually you will come to a time in the future where you can take them off altogether and have them, have the train run as a pure electric. To do that, you do need to do some ballasting, but there's not a lot of other modification that's required. So we look to the future. Where do we go next? And the UK government has a commitment to have zero carbon by 2050, and that's been extended into a commitment to replace all diesel-only passenger trains by 2040. Network Rail and Transport Scotland for Scotland are proposing extensive additional electrification, which I think is any engineering assessment of how you decarbonise a railway network, particularly an intensively used railway network with mixed passenger, metro and freight services, would say that the electrification together with a decarbonised national grid is the way to go. But obviously that can't happen overnight, and there are still reluctance to commit to a large scale of electrification given recent experience with cost and progress of some schemes. So what's likely is that there will be a programme of electrification, but battery EMUs or BMUs or indeed hydrogen trains will be used to fill the gaps in the network. There is a renewed interest in discontinuous electrification, either as an interim or as like a permanent measure. And again, battery trains are ideally suited to doing this. Battery technology as it stands is fairly advanced, but it's predicted to advance considerably in the next 10 years. And that's mainly on the back of developments in the automotive field and the off-road type field, where the power density, the cost, and the overall, if you want, capacity of battery systems will increase considerably. So to cater for this market, we build on the experience that we've had with the bimode trains so far. We build on the experience that we've had with the AT200 platform, and it will be a modular EMU, BEMU platform aimed at DMU replacement. We're not on our own in doing that, but I think the strengths not only of bimode experience, but also being able to kind of have a very, very modular approach to this is something that hopefully puts us in good stead. As well as that, we already have 6 years of BEMU operations in Japan. The picture at the bottom there is a BMU. This is runs on an electrified route until it again gets to the last 30 kilometres, where it runs on battery power, turns around at the terminal and comes back. And we can see operations like that are quite likely in the UK, as well as filling in the gaps between the electrified sections. In terms of battery charging, the most efficient way of charging your battery is to do it from your 25 kV overhead while the train's moving, but static chargers are also available. And I think in terms of our if you want, message to everybody is we know battery management is absolutely key to reliable operation, and that's battery management both in operation and environment and in kind of care and maintenance. You can. It's a very different situation to have a battery that's at 90% of its life as to one that's suddenly dropped to 50 because it's been mismanaged. So also then moving on from that, we are looking at how to decarbonise the diesel bimode. Again, current technology would allow us to replace one or more diesel engines with battery packs. The diagram at the top there is the kind of the traction schematic for a typical 5-car bimode. There are 3 motored coaches, 2 pantograph trailer coaches, and each of the motor coaches has got its own traction converter. So in very, very simple terms, you can take off the diesel engine and generator unit and replace it with a battery pack. That enables you to provide battery traction to one of the power cars, but you've also got a cross feed on the auxiliaries then into the other coaches should you desire. What we see at the moment is current technology will enable you to achieve the sort of performance that's shown in the graph below there, where the light blue line is the acceleration of a diesel bimode train up to 100 miles an hour. The dark blue line is if we have replaced one of the diesel engines with a battery, and as you can see, current technology doesn't quite allow us to get to 100 miles an hour and still have the range to be able to make it a sort of a viable system. But it's pretty close, and so that's where our efforts are focused at the moment, is to develop a viable battery pack to replace the battery units. Now that gives you both reduced fuel consumption, reduced emissions in stations and depots, reduced CO2, and also reduced noise, and does give you quite a bit of flexibility as to how you move the train about. In due course, we would see more than one diesel engine being replaced, but a lot of that depends not only on battery technology itself, but also on how to package it and manage it. We recently entered into a partnership with a company called Hyperdrive, who are based in the northeast of England. They're a kind of a spin-off from the Nissan plant in Sunderland, but their specialism is in taking very, very small battery cells and packaging them up into larger blocks for use in off-road vehicles, for use in industrial plants, and also for use in trains. This we think is the, if you want, the best route to market, given current technologies, to be able to get the earliest result and the earliest benefit. And then finally, in terms of the evolution of the train, I have to mention HS2. This is a live bid, so I can't, of course, talk about anything other than that's already in the public domain. But this is a new design of train, very high-speed train, suitable for operation in the UK. It's a classic compatible design, as they call it, so it runs on high speed 2, and it also then runs on network rail infrastructure on the routes that are indicated in the bottom map there. This is a joint bid we're doing with Bombardier. The partnership with Bombardier is proven through the ETR 1000, but it also enables us to manufacture in both Derby and Newton Aycliffe, spreading the HS2 investment around the UK regions. It is part of our mission, of our journey of developing UK skills, knowledge and supply chain. Train itself, technically very advanced, capable of 217 mile an hour or 350 kilometers an hour on HS2, and 125 mile an hour on network rail. Although again, I know it doesn't tilt, and so there are speed restrictions on the West Coast Main Line that it won't be able to fully take advantage of unless the rules are changed. Because of the sensitivities around, if you want, the efficiency of high-speed operation, that in the procurement process there's a focus on energy and noise, and The contract is due to be awarded by the end of March 2021, with the trains in service from 2027, and then all ready for when the high-speed route opens. Now, like I say, it is a live bid. We are obviously hopeful that we are chosen, but there is a competition, and as they would say on the BBC, other builders are available. But they say it's a very exciting project, and one that I think suits the evolution of high-speed train from Shinkansen through Class 395 through IEP, similarly on the Bombardier side of Zafiro through to ETR 1000 and through to this train. Evolution rather than revolution. So finally, in terms of wrapping up, we've come a long way since our first UK order for 395s in 2005. We've now got 270 odd trains in service. We are from what was originally a very small team of people in London as a very small art base from a very large Japanese manufacturer. We're now part of a global and integrated provider of rolling stock, maintenance, signalling, digital systems. We currently provide 13% of the UK passenger fleet. We've got more trains due to be delivered, and so that will increase. And I think I can honestly say that the AT300 or the Intercity Express is now the iconic UK intercity train. It's used on Great Western, on East Coast. It will be used on Midland Main Line, on West Coast Main Line. It's going to be going the length and breadth of the country. Newton Aycliffe does now manufacture complete trains, and we've got a growing UK supply chain, and we are developing the battery hybrid products that will be necessary to decarbonise the UK railway. And as I said before, hope to be part of HS2's future with Bombardier and the great British train. So finally then, keeping the evolutionary theme going there, this is a set piece that was arranged by East Coast on the introduction of their Intercity Express trains, which are branded Azuma with East Coast, and it shows the evolution or some of the evolution of traction on the East Coast Main Line over the kind of the last 40 years. So finally, and I hope I get this right, Dunaste Mondamo. Any questions?
Barry, thank you very much for your talk there. The questions have been coming in, so without further ado, we'll crack on and see if we can get through a few of these questions. So we've got a question here. It's quite straightforward in that the question asks, is it possible to build a third rail version of the Class 810, which I think is the mainline train?
Yes. So
okay.
Obviously you have to design the power pickups, you have to design the traction subsystem or the traction architecture, but the simple answer would be yes.
Good. Straightforward answer. Good. So we got another question here around the Newton Aycliffe site, and the question they ask is whether any manufacturing takes place on the site, and a secondary question to that are where are the trains designed, and I'll let you take those two.
Okay, so I'm just flicking back to the picture of Newton Aycliffe, right? So when we say does any manufacture take place on site, the current trains that are being built there, which are being built for the East Coast Open Access operator and soon to be built for Midland Main Line and West Coast Partnership, the car body is currently manufactured in Japan. So it comes in as a bare aluminium shell, and then everything from there is installed on site. So we believe that this is manufacture of trains. So the next stage, which is due for introduction next year, and the jigs are currently being installed at the moment, is to install a facility where we can weld car body panels into complete car bodies. So again, it increases the amount of manufacturing that's done on site. But the everything at the moment comes, it's a bare shell, and literally everything is installed on site and then tested and obviously put into service. Train design is split between Japan, Italy, and the UK. We have a well-established team in Casado in Japan who designed the 395, who designed the AT300s, who designed the AT200, and we now have people at Newton Aycliffe who can take that core design, particularly around the customer in interiors, and kind of make them more bespoke. Part of the Ansaldo Breda acquisition was we inherited the design capabilities in Pistoia in Italy, and so the AT300 SXR is primarily a Pistoia design, but again, in terms of customizing the interiors and where we go in the future, there'll be increasingly UK engineers involved in the design of that.
Thank you, Barry. Well, following on then from design, there's a slight design-related question here, which is, will the East Midlands AT300s have plug doors instead of the space-sapping sliding doors?
They have the sliding doors, and the reason behind that is to do with reliability and speed of operation. The AT200 trains for Scotland have a sliding plug door, but the AT300 bimodes all have sliding doors.
Okay, thank you. I think this question's come from a couple of different people, so it's I don't know whether you're able to comment on it, but are there any implications for the HS2 joint venture with Bombardier following the acquisition of Bombardier by Alstom?
So we have submitted our bid, and the acquisition, which again, there's been a public, if you want, public dialogue through the European Union, is it doesn't affect it. So I think the simple answer is no. Both parties are committed to it, and may the best bidder win.
Okay, excellent, thank you. So I have a question around hydrogen battery trains, so it's been noted that JR East, Hitachi and Toyota are planning to collaborate on a prototype hydrogen battery train in Japan. And are there any similar developments in the UK, perhaps where the distances and duty cycles are not best suited to battery only?
So the trial in Japan is something that we will watch with interest, learn what we can from it, and given a sort of a modular design of traction equipment on the train is something that if the market was there, then could be adapted for the UK. If you look at the economics around hydrogen, then I have to say that they're not good. It's quite an inefficient way of transferring energy, but it does have its supporters. It certainly has a powerful lobby behind it, and so we wouldn't rule it out. But I think the areas that it can economically be employed are fairly limited. And of course, you mustn't forget at the moment that hydrogen all comes from petrochemicals. And so you know, until there is a means by which there's a sustainable means of producing hydrogen, and then an economical way of being able to store it and transport it and use it, the costs will always be higher than a battery train, which you know is the battery train makes what use of the electrification there is, and doesn't have a lot of shoreside equipment supporting it. But say what we have done in the past is we've taken technology that's been developed in Japan and brought it in, and again, given the right market conditions, we'd do the same again.
Thank you. I have a question around track and infrastructure. What are the main considerations from a track maintenance perspective for the bigger, faster, and presumably heavier high-speed trains?
So, track maintenance, you're looking at weight, you're looking at speed, you're looking at the kind of the cornering forces, and the more intensively used the service is, obviously the more that is. I mean, typically for a UK project, there is a fairly standard network rail calculation, which is called VTAC, and that is used to, if you want, assess the track maintenance implications of any particular train design and proposal. So to minimise your VTAC is always seen as being a good thing, and to minimise your VTAC, you have to reduce weight, reduce your unsprung mass, reduce your stiffness. You know, all those things that people who have been involved in train design and track maintenance for many years will tell you is kind of, it's what you have to do. A bi-mode train and a battery train and a hydrogen train will be heavier than a straight EMU, which is why, again, the economics of electrified railways are good in so many ways. I mean, that's the way to keep your weight down, is not to have to carry stuff around that you don't need to. But VTAC is how the impacts for track maintenance is conventionally calculated in the UK, and so all manufacturers seek to minimise their VTAC.
Okay, so are the manufacturers incentivised then at the procurement stage to reduce their impact on?
It does depend how the procurement's. Yeah, it depends how the procurement's done. In the simplest case, it's something that the operator will use on their back of an envelope to calculate how much it's going to cost them to run these trains. In the more sophisticated procurements, it's part of the evaluation model. And so, let's say the larger, more sophisticated procurements have this built into their financial evaluation. So yes, that's how the manufacturer is incentivized to keep it to the lowest level.
Okay, thank you. Question about obsolescence and how does Hitachi deal with obsolescence of systems and subsystems on your trains? Is that a particular problem for you?
Yep. Well, yes. I mean, any designer, manufacturer, and supplier of sophisticated and particularly electronic, but also mechanical systems has got to deal with obsolescence. Trains are a fairly long life asset, and technology and suppliers move on in that time. So the best way to protect yourself on obsolescence is to have a manufacturer maintenance contract, and then the manufacturer is incentivized to manage the obsolescence for you and to source and procure like-for-like components when needed. If you haven't got a manufacturer maintenance contract, then that's in terms of can that be managed? Yes, it can, but you need to either pay somebody else to do it, or pay the manufacturer separately to do it. But it is a problem. It has been a problem on trains in the past, and it is a problem now. Suppliers come and go, designs come and go, standards change, and so you need to keep abreast of it. But definitely best way to do it is through a manufacturer maintenance contract, which I would encourage anybody who's thinking of buying a new train to take out.
Good advice there, prospective train buyers. So a question which was generated about this weekend's movement of the first 8300s from St Pancras into St Pancras, sorry, the whole trains. Now, it's I believe they weren't allowed to use the 25 kV lines from Kettering. And do you know why this was?
So I wouldn't specifically know for that service, because of course Hull Trains arrange the access, and of course it is a sign. I mean, again, the flexibility of the train is that you don't need to use the electrics. You can use the diesel. But I do know, if you look at the build of trains that are being done for East Midlands at the moment, the 8300 SXR, is they won't be able to use the overheads between St Pancras and Bedford, and then from Bedford on to Kettering, until the power supply is upgraded. So there's a speed and a power supply issue on the existing overheads. I think if you look at the newly installed bit between Kettering and Bedford, I wouldn't imagine that there has been many trains approved to run on that section. So there would be a lot of work would be required to do that. And if you've got a diesel bi-mode train, which you're using for diversionary purposes, as Hull Trains are, you probably wouldn't want to go through the effort of doing that just for a few weekends service. But the medium-term age is to have the bi-mode trains running on electric from St Pancras to the end of the wires, and whether that's Kettering or Market Harborough or Leicester or Derby or Nottingham or Sheffield, the trains are ready for that.
Excellent. With the you covered decarbonisation in your presentation, and there's a question asked about if diesel engines are removed, why would ballast have to be fitted? Surely other adjustments could be made to avoid carrying useless mass.
Yes, you would think so, wouldn't you? But the engineers tell me that we need to fit some ballast to enable the suspension and the car body design to function normally. Obviously, you'd want to minimise that, but the engineers tell me at the moment that we do need to fit some ballast.
Okay. Thank you. Let's see. You covered that some of the Avanti have purchased some trains, but they're not tilting, which we used to on the West Coast Main Line now.
Yep.
Someone asks if there is any reason that a tilting mechanism has not been considered in your train builds to enable faster travel.
Yes, I mean, there's the simple answer would be the client did not deem it necessary. The client was looking for a train that could be 125 mile an hour where allowed, or 110 mile an hour without tilt, and we were able to meet their journey time plans, with a non-tilting platform. There is a Shinkansen design in Japan and in Taiwan, I think it is, that does tilt. But whilst it could have been considered, it wasn't something that featured into the thinking for the West Coast Mainline fleet. it wasn't necessary to achieve the journey time aspirations.
Right. Okay. Would would using a non-tilting train, or are you restricted on the routes then that you can run with the non-tilting trains at high speeds? For that fact
so
thing?
the West Coast Main Line, has got a number of what are called enhanced permissible speed sections, where trains that tilt, and specifically the Pendolinos and the tilting Voyagers, can run at 125 mile an hour or can run at a higher speed than trains that don't tilt. So if you are running long distances non-stop, then that has quite an effect on the journey time. If you are primarily stopping at intermediate stations or running on sections that are not covered by enhanced speed restrictions, then the journey time benefit is less obvious.
Okay. Right. We'll conscious of time, and you've been speaking for a long time, Barry. So one final question: are there any plans to manufacture Hitachi bogies in the UK?
Not at the moment. Is a suitably teasing answer, but yeah. No,
okay, so then we can maybe read. Can we read anything into your answer? Well, only time will tell. Time will tell, perhaps.
I mean, I would never say never, and again, a lot depends on where your volume's coming from. Increasingly, manufacturers can do a design and build anywhere type function, and Hitachi's not kind of out of that. So the business of building bogies, there's a lot in the design, there's a lot in the procurement of the equipment, and then there's an assembly of them. So I say we don't have any plans yet.
Thank you. Okay, well, I'd like to just draw the questions and answers to a close there, and I'd like to invite Jen to give the vote of thanks.
Okay. On behalf of the Southeastern Division, I'd like to thank Barry for his lecture today. The excellent summary you provided of the history of the Hitachi trains in the UK and the variations in the designs was very insightful. It was particularly exciting to hear about Hitachi's response to the decarbonisation movement, something that is very topical, with the move to battery technology, and we are looking forward to seeing how Hitachi continues to develop in the future. Thank you to the audience for engaging in that varied Q&A session, and of course thank you to the IMechE team for facilitating the lecture today.
Thank you. It's been my pleasure.
Great. Thank you very much from me also, Barry, and thank you, Jen, for doing the vote of thanks. One final thing before we wrap up, which is just to let everybody know of our next event, which is going to be jointly organised and run with the North East Centre, and that will be on the 17th of November at a slightly later start time of 6:30. That presentation will be from David Shires, editor of Rail Magazine, and he will talk about rail decarbonisation. So something, if you want to carry on the debate on rail decarbonisation, this one is probably one to attend, as David has written extensively on the subject, and he will explain how the rail industry decarbonisation task force has concluded that rail decarbonisation can only be achieved with a judicious mix of electric, battery and hydrogen traction, and he'll expand on the role of each type of traction in a net zero carbon railway. So that brings us to the end of tonight's talk. Thank you everyone for attending. Thank you once again, Barry, for your excellent presentation, and I hope to see you all again soon at our next webinar. Thank you. Good night.